Hello everyone, I welcome you all back to this channel. In today's episode of our solar energy systems design and installation training, we'll be discussing charge controller over paneling. Solar charge controller over paneling. Now, what does solar charge controller over paneling mean? It is very simple. Let's say you have a solar panel whose power rating or the wattage is, let's say, 4,000 watts. And during solar system installation, you connect 5,000 watts instead of 4,000 watts. That is what we call solar charge controller over panel. That is just the simple meaning. When you connect more solar panel than the rated solar wattage of your solar charge controller, it is what is called what? Solar charge controller over paneling. Now, why do we need to over panel solar charge controller? There are three basic reasons why we need to what? Over panel solar charge controller. The first one is it will enable you to generate more power with the same solar MPPT charge controller. That is the first one. The second one is the cost of what? The cost of electronics. You know, solar charge controller per wattage consideration are more expensive than your solar panels. Let's say you are installing a system. You have 5 kilowatt panel to install. Then the available solar charge controller is rated for 4,000 watts. That is 4 kilowatts. So instead of getting additional solar charge controller for the difference of 1 kilowatt panel you have on ground, there is a way you can actually play around it and connect everything to your solar watt, to that particular available solar charge controller. Now, there are some things we need to consider, which we call the add limit. So those electrical limits must not be what? Exceeded. If you are over paneling your solar charge controller, you must be what? Take note of something so that you don't end up flying your solar charge controller. Now, before then, basically we have two types of solar charge controller. We have the PWM solar charge controller, then we have the MPPT solar charge controller. Please note, the PWM solar charge controller is not smart enough to accommodate more solar panel. So the concept of over paneling does not work with PWM solar charge controller. Now, if you are designing your solar charge controller, there are some things you need to take note of. Let's say in the case of PWM, you consider the short circuit current, then the number of parallel string, then you multiply it by the safety factor. In the case of MPPT solar charge controller, you consider the total wattage of solar panels you are installing, then you divide by the battery charging voltage times the safety factor. Now, what are those hard limits that must be put into consideration? The first one is, now there are basically two hard limits that must be put into consideration, or we call them the electrical limit. Before you over panel your solar charge controller, you need to consider these two things. The first one is the maximum solar voltage. the what? The maximum solar voltage. You know, in your solar charge controller, you will see the what? The solar voltage range, the maximum and the minimum. On no condition will this be exceeded. Please take note. The maximum solar voltage of your charge controller should not be what? Should not be exceeded. If you exceed it even by a unit during cold weather, you will end up frying your charge controller. During cold weather, the panel voltage tends to rise. So let's say you have a solar charge controller with a maximum voltage of 100 volts. Then you are connecting, what is it called? Then your total solar array voltage you are connected to this charge controller is 100 volts. There is every tendency that during cold weather, this value can rise beyond this. So your total solar voltage, which is 100 volts, there's every tendency that during cold weather, it can shoot above this. And what happens to a solar charge controller? You end up frying it. So that is why it is advisable that if you are designing your solar charge controller, you must give a space like 20% space. Let's say I'm working with a solar charge controller of 100 volts and I'm connecting a solar panel. Let's say I have a 2 string of solar panel to connect. You must make sure that in a string, what you are getting is around 80 volts. So there should be 20% allowance. The reason for this is that during cold weather, no matter even if the voltage should top, it will not get to what? To 100 volts. So there should be allowance. So even in your solar charge controller over paneling, this should also be put into consideration. Then we'll talk about the second one, which is the maximum PV current. What is the maximum PV current? The maximum PV current is not, there is what we call the short circuit current. Let's say there is a short circuit fault. Definitely your solar panel will generate more than the maximum panel current. So in this case, we say the maximum PV current is the net short circuit current. If you are over paneling your solar charge controller, the net short circuit current must not be more than that of what your solar charge controller. I know you will ask, where do I find short circuit current on my solar charge controller? There are some solar charge controller you can actually see short circuit current, both written a brand like Victron and the other premium brand. But even if the one you are working with, the short circuit current is not stated, there is a way you work it out. You use a safety factor of what? 25 to 30%. You use a safety factor of what? 25 to 30%. That means if I am working with 60 amp charge controller and I want to over panel this, I can take 25% of this. I can size this 25% over. So that means even if I am sending in current of 75 amps, I am safe. 75 to 80 amps, I am safe. Because you are considering this safety limit. So 60 amps is your rated current. So the hard limit, which is the short circuit current. Now, your own solar charge controller, it is not indicated. You want to work it out. You apply 25%. No, 25%. That gives us 125, right? That is 1.25. 25% over, that is 125%. By the time you divide by 100, it gives you 1.25. Multiply 1.25 by 60, and you should be getting 75 amps. That means if your solar charge controller is 60 amp and you are setting in current of what 75 amp, it is still very, very what okay. But ensure that the value of the current you are setting in is not more than 75 amps, because that is the hard limit. If the value of the current shouldn't what exceed 75 amps. So that is that. So please take note of this what hard limit. The first one is the maximum solar voltage. The second one is the maximum PV current, which is the what the short circuit current. Now, what works best for over paneling? I will tell you it is what it is series or string connection, because you know in series connection what happen? Series connection, the same current flow while the voltage add up. So in parallel connection, what happen? The voltage remain the same while the current add up. So it means in this case, you see that series connection favor solar charge controller over paneling more than what parallel connection, because here the current add up. Because you must make sure that whatever current you are pushing in must not be more than what the short circuit current of your solar charge controller. So that is that. Now we now talk of the application of what over solar charge controller over panel. So the first one is the grid tied then off grid solar system, or we call it the standalone solar system. So solar over paneling are mostly what applicable in grid tied solar system and off grid what solar system. Now in grid tied solar system, so there is a reason why this solar panel over solar charge controller over paneling is very, very what important if you are doing a grid tied installation, and it still depends on the location, the part of the world where you are doing what the installation. You know, I made mention of the reason why you have to over panel, because it will enable you to harvest more solar panel with the same MPPT solar charge controller. And the second one is the cost of electronics. You know, solar charge controller is more expensive, so it is better to buy more solar panel than buying additional solar charge controller. It's better to over panel the one you have than buying additional one to take care of the excess solar panel. So the third one is the tax. The tax, because there are some countries that the tax they tax based on what the inverter size. Let's say the tax rate, let's say for instance, is $10 per kilowatt. Now you are installing, let's say 10 kilowatt inverter, 10 kilowatt inverter. Definitely 10 times 10, you will be paying what $100 for 10 kilowatt. Now, if you install 14 kilowatt, you'll be paying what $140 as your tax. Now, there is a formula for solar charge controller over paneling for string inverter. For what grid tied inverter, so AC ratio is equal to 1.4 is equal to 1.4. This is the formula if you are working with what if you are working if you are installing grid-tied system. So this is the formula you apply for what? For over paneling. So I've told you the reason why you need to over panel. Aside the cost of the extra charge controller, if you are buying a big inverter, you will also have to pay what? More tax. That is, if you are buying a bigger inverter for the same project, you will have to pay what? More tax. So in this case, we say the formula is DC to AC ratio is 1.4. Let's say you are working with 10 kilowatt inverter. 10 kilowatt inverter. Then we have DC over AC, which is what? 1.4. The DC, the AC is 10 kilowatt, 1.4. I mean DC is equal to 1.4 times 10. This gives us 14 kilowatt. What means is that if you are installing a grid type system and you are working with 10 kilowatt inverter, you can actually connect 14 kilowatt solar panel to your 10 kilowatt inverter. So that is just the simple meaning. So let's say you are now installing 5 kilowatt. 5 kilowatt, it means you can what? You can connect 7 kilowatt solar panels. So that is that. Then we now talk of what the off-grid solar system. So the solar charge controller is very, very important in what? Off-grid solar sector. Now I've already discussed this, what you need to consider. The first one is your hybrid inverter or your external charge controller maximum solar voltage must not be exceeded. You should even give it an allowance, like 20% allowance. If, for instance, the maximum solar voltage is 100 volts, your net solar voltage should be around 80 volts. So that will take care of days of maybe a freezy days where the voltage might shoot up. And the second one is your total PV current should not be more than what the short circuit current of your solar charge controller. And we said that there are some charge controllers you will not see short circuit correlating. All you just need to do is to take 25% of the rated current of the solar charge controller. Let's say you have 60 amp solar charge controller, multiplied by 1.25. That will give us 75 amps. So whatever you are connected, that 75 amp is the hard limit. It must not be exceeded for any reason. So whatever you are over paneling, you must not exceed what? 75%. And I tell you, there are even ways you will do your connection. You will over panel and you will not even exceed the 60%, which is the current rating of the side of the charge controller, the amount of current it can output. Now the question is, if you over panel your solar charge controller, what happens during peak sun hours? That is the question. What happens during peak sun hours? So this is the reason why I said you cannot over panel PWM solar charge controller. It must be MPPT because PWM is not smart enough to take care of what? The excess panel. Let's say your solar charge controller, for instance, can take 4 kilowatts and you connect 5 kilowatts. For instance, let's say during peak sun hours, you are getting, let's say 4.5 kilowatt. Now what happened to the 0.5 kilowatt? You understand? The charge controller will clip it off. That is what we call current clipping. We have a clipping effect of a solar charge controller. So the excess will be what will be clipped off. Because what the solar charge controller does that it operates within its limit. So it will only take the 4 kilowatt and leave the 0.5 watt kilowatt. Now this is why overpaneling is very, very what important. Let's say in this, let's say or very early in the morning. So it's enable your battery to get fully charged faster. Because in the morning you will be what is it called? You will be getting something. If the total panel that is connected, let's say in the morning you are getting 1 kilowatt, you understand. But with 5 kilowatt, you should be getting like let's say 1.3 kilowatt. You see the excess. Secondly, on rainy days or cloudy days. So where a solar panel will actually make you to generate more power, so that your battery can get fully charged, and also supply the loads that will be running in the daytime, regardless the weather. So that is the essence of solar over panel. So if you over panel your solar charge controller, you must make sure the place is well ventilated, because the solar will be operating at its maximum capacity most of the time of the days. So the controller must be well ventilated. That is that for off grid. So I've told you what you need to look out for. In the case of grid tie, I've showed you the formula you need to apply and the reasons why this solar panel, solar charge control of a panel is very important. I will also advise you, it still depends on the controller you are working, or you can still do some research about the particular controller you are working with. So with this, we bring today's episode to an end. Please don't forget to always like our video, share, and always drop your comments. What you think about this particular class, drop it. Don't forget to subscribe and hit the notification button for our subsequent episode. Thank you and bye for now. I can take 25% of this. I can size this 25% over. So that means even if I am sending in current of 75 amps, I am safe. 75 to 80 amps, I am safe, because you are considering this safety limit. So 60 amp is your rated current. So the hard limit, which is the short circuit current, now your own solar charge controller, it is not indicated. You want to work it out. You apply 25%. No, 25%. That gives us 125, right? That is 1.25. 25% over, that is 125%. By the time you divide by 100, it gives you 1.25. Multiply 1.25 by 60, and you should be getting 75 amps. That means if your solar charge controller is 60 amp and you are sending in current of 75 amp,